A circular space station could be built using current or near-future technology, but it would be one of humanity's largest engineering projects. Its massive scale would require unprecedented international collaboration and resources. This is a rotating space station orbiting Earth. Its outer ring rotates around the central hub. This rotation creates artificial gravity on the inside. On this inner surface, people can live and work. A larger station is generally better because it can produce comfortable artificial gravity with slower rotation. What would it take? Huge quantities of material. The station would need structural metals, composites, radiation shielding, glass, electronics, machinery, life support equipment, and enormous amounts of propellant. Launching everything from Earth would be prohibitively expensive, so a realistic large station would eventually obtain much of its raw material from the moon or asteroids. A rotating structure would fetch an enormous force induced by rotation. A rotating structure, the rig would understand instead in malts from materials from the maltostorus asteroid.
The rotation is steady today. Gravity feels perfect. This atmosphere is so fresh. The plants really help. Time to check the other modules.
The system would need to be extremely redundant because there would be no convenient way to evacuate thousands of people. Radiation protection is one of the biggest problems. A thin metal shell isn't enough for long-term habitation. The station would need substantial shielding, potentially using water, regolith, polyethylene, or other hydrogen-rich materials. A fascinating possibility is using lunar material as a thick, protective layer around the habitat. What could be inside? A sufficiently large circular station could contain surprisingly large environments. Water reservoirs in large tanks could simultaneously provide water and radiation shielding. In a sufficiently enormous habitat, you could create environments that feel surprisingly Earth-like. How would you build it? A realistic development path might look like: Stage 1, small orbital construction platform. Build the first assembly station in orbit. Stage 5, rotation initiated. The completed structure is gradually spun up. Stage 6, pressurization. Habitable modules are tested and slowly filled with atmosphere. Stage 7, agriculture and life support. Food production, water recycling, and oxygen systems are brought online. Stage 8, permanent habitation. People begin living there continuously. The really interesting possibility, instead of building the entire station in one piece, you could build it like a gigantic spacecraft construction kit. Integration complete. Life support is stable. Next module docking now. Individual sections could be launched separately, assembled robotically, connected into a ring, and progressively expanded. Eventually you could have something like Earth, orbital construction yard, lunar mining, material transported to orbit, enormous rotating habitat. And if the station became sufficiently large, this giant rotating ring space station orbits Earth without a central hub. Its toroidal shape provides stability through rotation. This design allows for efficient construction and modular expansion. A marvel of engineering, built for life in space. This ring habitat solves a key problem: artificial gravity through rotation. Living areas like homes, labs, and farms line the circumference. The center is open space, providing a vast vista. But rotation creates immense structural stress, a major engineering challenge. This is a rotating space habitat. Its spin creates artificial gravity on the inner surface. The difficult part isn't the central hole, it's making the ring strong enough to rotate safely. This design allows inhabitants to look across the void and see the opposite side of their world.